The last video for section 4 gets a little bit more into some terminology initially. So we've been talking about angles and specifically how we measure them. Let's talk now about how we might label them. Okay, so there's a nice little picture right here. If an angle measure is between 0 and 90, we call it acute. If it's exactly 90, we call it a right angle. If it's between 90 and 180, it's obtuse. And if it's exactly 180, we call it a straight angle. And for most of what we do, the angles will never get above 180. So from there, I want you to be referring to these notes here a little bit, but I'm going to ask you about 3 questions here. We're going to measure an angle like we did in the previous video, and then we're going to label it as acute, right, obtuse, or straight. So we're going to do it kind of quickly. And I'm going to probably take up all the space for each example. You're going to want to try to fit that in, all 3 examples kind of in this space right here. So the first angle that we're going to look at, the first measure, let me get my iPad ready here. There we go. We're going to look at the measure of angle LKN. So what's the measure of angle LKN? Okay, so we need to figure out some of the numbers that go with that. So LKN is this angle right here. Okay, the way I would measure this, I would start at the 0, because that's lined up nicely for us. Notice the vertex is still at that important point. It's lined up at 0. So if we just count up this way, follow the bottom numbers all the way to where the L ray kind of leads us, we end up at 145. That's going to be the angle measure. That one really required no substitution, or no subtraction, excuse me, if we did it kind of that easy way. So that's our angle measure. If we look up at the chart above, if you are between 90 and 180, your angle is called obtuse. Okay, so that's maybe the first thing to consider. Let's clear this away. Next angle is going to be angle JKL. Okay, so let's look at that one. Angle JKL. Here's J to K to L. So this one is not lined up on that nice baseline, so we need to do a little bit of work. A couple ways that we could do it. We start at, maybe we'll use the top row this time. It's lined up at 90 on the top, also 90 on the bottom, but let's just look at the 90 on the top, and also at 35. So take the big one minus the small one. We go 90 minus 35. You can do that on your calculator if you need to. You can try to do it in your head, but I believe we would get 55 degrees. Okay, and if angle, according to our notes, is between 0 and 90, we call it acute. Okay, so that one is done. Erase this again. There we go. And our last one is angle JKN. Angle JKN. Okay, so J is up here. There's K, that's N. Okay, so this one, the vertex again is at the special point. It's on the baseline, so I would choose to start at 0 down here and just follow the numbers up. I get exactly 90 on the bottom when I end up, so that's the angle measure, and that makes it a right angle. Okay, so that's not so bad, not hopefully too difficult. You're still measuring angles, then you just add a label to it. Okay, another just important thing about notation. Just like we have congruent segments, we also have something called congruent angles. That means that the shapes look the same. That is different in the geometry world than saying the measure of the angles are equal, but it still kind of means the same thing. So we've been talking about maybe finding angle measures, putting a number to it, and that's when we use this notation, especially with an equal sign right there. But if the shapes in general, if all we're worried about are talking about the shapes are congruent, we use that congruent symbol again, and we just use the symbolism just for a normal angle. Maybe one thing to take away is that if you want to show the shapes are the same, you just put a little arc there. If you had lots of those angles and you wanted to distinguish the pair, like maybe you already had an angle pair that had that arc, then you would just start adding, let's see if I can do this, you'd have 2 arcs in there. Or if you had already had 2 pairs of angles, you'd mark this with 3 arcs. So you can keep doing that as many times as you need to signify that these are unique pair of angles. Okay, and the last thing that we're going to look at is something called the angle addition postulate. You can just call it a general rule, very similar to what we did with segment addition. If we have angle AOB, which is this part right here in kind of a tannish color, and angle BOC, which is in the light blue. Together, they will form the measure of angle AOC, so the larger angle combined. And again, I think that kind of makes sense. The degree measure here plus the degree measure there should get us the overall degree measure. So we'll just do a quick question involving that to finish off our notes today. Oops, didn't quite need to do that. Let's just provide a little bit more space there. There we go. So we have the angle RQT, the measure of angle RQT, which is the big one according to this. That's 155 degrees. RQS, which is this one right here, is 4x minus 20. And TQS, so T to Q to S, is 3x plus 14. So how do these go together? Well, this plus this have to equal the overall large angle. So that means algebraically that 4x minus 20 plus 3x plus 14 has to equal the total, and in this case that's 155. Okay, so we go through and just do some general algebra again. 4x and 3x gets us 7x. A negative 20 and a positive 14 gets me negative 6. And that's going to equal 155. Okay, so I want to move some different pieces around here. So I'm going to add 6 to both sides. So I still have 7x on the left. And on the right I would have 161. Okay, now this is going to be a little bit of a more difficult problem, perhaps not as familiar, but you divide both sides by 7. When you do that, oops, I'm running out of space here on my. Here, I'm going to have to do this right over here. When I divide both sides by 7, I should get x is equal to, I believe, 23. Okay, and so that's kind of the end answer here. I suppose what they're really wondering is what are we going to get for the measures of RQS and TQS. So all you would have to do then is take this 23 and plug it into the x there, simplify this. Take the 23, plug it in for this x, simplify this. Together those two new answers should get us 155. So I might just leave that up to you to see if that does work out in the end. Okay, thanks for watching, and jot down any questions you might have.